Turning e-waste into a functional robot. Building a robot companion from e-waste is an innovative way to recycle old electronics while exploring robotics. Many discarded devices, such as old laptops, printers, and smartphones, contain useful components like motors, sensors, and microcontrollers. By repurposing these parts, you can create a functional robot that serves as an assistant, pet, or even a learning tool. Gathering useful components from old devices. Start by collecting e-waste from old gadgets that no longer work. Useful components include servo motors from printers, circuit boards from computers, and cameras from smartphones. Batteries from discarded devices can power your robot, while plastic casings can be repurposed for its body. Carefully disassemble these electronics, making sure to handle circuit boards and batteries safely. Choosing a microcontroller for robot control. A microcontroller, such as an Arduino or Raspberry Pi, serves as the robot's brain. If you salvage an old computer or smartphone, its processor may also be repurposed for basic AI functions. The microcontroller processes input from sensors and controls movement, allowing the robot to interact with its surroundings. Open-source software makes programming easier for beginners. Designing the robot's mobility system. Repurposed motors from DVD drives or RC toys can be used for movement. Wheels from broken remote control cars or salvaged gears from printers can provide mobility. If building a stationary robot, rotating parts from old fans can be used to create simple movements like nodding or waving. The key is to match motor power with the weight of the robot. Adding sensors for interaction and autonomy. To make the robot interactive, add sensors from discarded devices. Old webcams can be used for visual input, while microphones from phones or headsets can enable voice recognition. Infrared sensors from remote controls allow for object detection, helping the robot navigate its environment. These sensors enable basic eye-driven behaviors and responsiveness. Creating a power source from recycled batteries. Batteries from old laptops, power banks, or phones can be reconditioned to power the robot. A power management circuit, often found in laptops, can regulate voltage and prevent overheating. Solar panels from broken calculators or outdoor lights can also be repurposed for an eco-friendly charging system. Safety precautions should be taken when handling old batteries. Programming the robot for smart functions. The robot's personality and functions depend on programming. Open-source AI tools and voice assistants, such as Google Assistant or ChatGPT APIs, can be integrated for smart responses. If using Raspberry Pi, Python scripts can enable voice recognition and movement. Beginners can use simple drag-and-drop coding tools like Scratch to program basic interactions. Assembling and customizing the robot's design. The physical assembly of the robot depends on available materials. Repurposing plastic casings from old gadgets can shape the body, while screws and brackets from discarded appliances can provide structural support. A 3D printed frame can be an option if you have access to a printer. Customizing its design with LEDs, recycled buttons, or artistic elements gives it a unique personality. Testing and improving robot performance. After assembling the robot, run tests to ensure all components work together. Check motor responsiveness, sensor accuracy, and power efficiency. If any issues arise, tweak the software, reposition sensors, or replace faulty components. A well-built robot can be continually upgraded with new features over time. Promoting sustainability through DIY robotics. Creating a robot from e-waste not only reduces electronic waste but also encourages creative problem-solving. By sharing the process online or in maker communities, you can inspire others to recycle electronics innovatively. This project showcases how technology and sustainability can work together, turning discarded devices into useful robotic companions.